Hi everyone, this is Alicia, and I wanted to talk to you today about a document that the coaches and I have been working on. This document is being created because we were asked by teachers recently, what exactly can we expect our students to be responsible for on the STAR for Algebra 1? So that conversation starts with the Algebra 1 blueprint, which is what's in front of you right now. This blueprint is made up of the five categories that our students will be tested on. Each of the categories are broken up into readiness and supporting standards. So it tells you how many of each kind of standards you can find in these categories. And then it tells you how many questions you can expect over each one of these categories. At the bottom here, it tells you what the test is broken down, how there will be 49 multiple choice, 5 griddable, 54 questions total. Now that 54 questions is 54 questions that our students are responsible for. There could be additional questions, and actually probably will, but those questions will be the field tested questions. It also talks about that we can expect 60 to 65% of the test to come from the readiness standards, and 35 to 40% of the test to come from the supporting standards. Now from here, we went to look at the side-by-side so that we could figure out how the blueprint and the side-by-side matched up to let us know what would be overlap or not. So we created a document for you, and this is the document. The document is titled the STAR TEKS Comparison for Overlap. This one is by TEKS. There's a second one that's by unit in case you wanted to look at it that way. It's dated 2015-2016 because this document will only be good this year. Starting next year, our students will be responsible for all of the TEKS on the STAR. So let's look at how this document is laid out. It's laid out by category, like I said this one is. So this is our first category, and it is showing you the TEKS, whether it's readiness or supporting, the number of questions that we can expect for this TEK based on, I'm going to pull up the blueprint again, based on what we're told here on how many questions there are and the percentages that they give. And then it has some information here, some guidance that was given by TEA, either on the side-by-side or through emails or other conversations that we've had with TEA. That way you have the information that we know. So this particular TEK, the student is expected to factor, if possible, trinomials with real factors in the form of ax squared plus bx plus c, including perfect square trinomials of degree 2. That is a readiness standard. You can expect 3 to 4 questions, just like we talked about. And it is overlap. Okay, so that's how you read the document. We did put our readiness first and supporting to follow. So I'm going to scroll through it because there are a couple of interesting things that I want you to see as we move through. Oh, I wanted to talk about this real quick. So notice A11A. It says the student is expected to support numerical radical expressions involving square roots. Well, that's a supporting standard, but it has 0 questions. Why is it got 0 questions? That's because this is a new standard. So the students would not be responsible for this particular TEK on the STAR. Now, does that mean that they won't see a question that involves simplifying radical expressions? And the answer to that is no, that's not what it means. There could be a question on this on the STAR, but if there is, then it's one of those field tested questions, and it cannot hurt or help our students. It just is there for them to test. Okay. So again, as we were creating this, I saw a couple of things that were interesting, and so I'd like to bring them to your attention. So I'm going to scroll down until we find one of those things, and here's one of them. So A3E, the student is expected to determine the effects of the graph of the parent function f of x equals x when f of x is replaced by all the transformations. So this is about linear transformations on our parent function of our linear parent function, right? It's a supporting standard, and we can expect 0 to 1 questions on that. Now, notice this one is overlap and new. So overlap, here's some guidance for us. And it says that mx plus b has been replaced by a of f of x plus d. Now, that doesn't mean that it's new, right? It just means that we've written notation differently. And so that's why this overlap is the same. It says that students should apply combinations of transformations to the linear parent function. So the combination piece I bolded because there's been some discussion about whether that's just an individual transformation or a combination of transformations. Now the transformations that are not new are our vertical transformations. Notice here the new piece, recognizing the effects of horizontal parameter changes of a linear function represented with function notation. That is new. Okay, so part of this TEK is not new, and students will be responsible for it. Another part of the TEK is new. That doesn't mean they won't see it, because it could be field tested, but it won't count for or against them. So as we scroll down a little bit more, here's another TEK I wanted to talk about. So A3G says a student is expected to estimate graphically the solutions to systems of two linear equations with two variables in real-world problems. So it's systems, not new. We look over, oh look, overlap. That's exactly what we expected. So why would I bring this to your attention? And it's because of the guidance that came with it. So it said the coordinates of the solution may be rational numbers. Scales on the graphs may include rational numbers. Now, I do believe that our students see problems that have rational numbers as a solution. I'm not sure that we give scales on graphs to include rational numbers very often to our students. So we need to think about that and consider starting to scale our graphs a little bit differently so that our students have opportunities to see scales like that and will not be surprised if they see it on the star. Like I said, this guidance came from TEA. So scrolling down to look for another one, because I know I have one more at least. Scrolling down, Oh, here's one. So A7B. Oh, this one. All right, so category 4 is quadratic functions and equations. Now, we had quadratics in our past TEKs, but they, again, remember, a lot of those questions fell into one category, nonlinear, and now it is a category all to itself. So I'd like you to notice we have a readiness, we have readiness, we have a readiness. Wow, this one has a lot of readiness. So notice that's why the readiness has only 1 to 2 questions in this particular category, and that's because there's so many of them. But then when we look at supporting 0 questions, oh, that's because it's new. Supporting 0 questions, that's new too. Supporting 0 questions, that's new too. There is only one supporting standard that is overlap here. Now, what does that mean? Well, according to the blueprint, 4 questions should come from the supporting category for category 4. But that means that this one standard could have, probably does, 4 questions on the EOC. We need to make sure that we watch that. You have not started this section yet, this unit yet, or this part of the unit is what I should say. And so when you're planning for this, you need to take this into consideration, that this particular TEK is going to count for 4 questions. We need to make sure that our kids master this. So what is this TEK? The student is expected to describe the relationship between the linear factors of a quadratic expression and the zeros of their associated quadratic functions. So they gave us a little bit of guidance on that, and it says the expectation is that students use multiple representations to describe the connections between the linear factors and the zeros of the associated quadratic functions. So we need to make sure that we're giving our students plenty of opportunities to make those connections. And if you have any further questions on that, you want to talk to your coaches about it. All right? So I know there's one more thing that caught my attention, and that is category 5, all of it. So category 5 is exponential, and in the past there was one TEK that was represented on STAR for that, and it is actually in front of you right now. It was a supporting standard, so it had 0 to 1 questions that could come from this TEK. So the TEK was A11C. Again, that's your old TEK. It's analyze data and represent situations involving exponential growth and decay using concrete models, tables, graphs, or algebraic methods. So that one TEK had one question, if one, on our EOC. Well, what the state has done is they've said that one TEK actually needed some more defining. So they took that TEK and they say that they broke it up into 5 TEKs. So all of this right here represents that one TEK, is what the TEA has said. So I'd like you to notice on the notes, overlap, 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 overlap. Why are all these overlap? Because all of these come from this one TEK. So we need to be careful and make sure that we have given our students plenty of opportunities to experience all of these TEKs in reporting category 5, because where it used to be worth 1 question, it is now worth 6. So we need to make sure that our students have plenty of opportunity to experience that. So where would I spend our 5 days if you have that many to review for STAR? One thing, I would definitely make sure that I spend some time on exponential functions, since we know now that it's going to be 6 TEKs instead of just 1. 6 questions instead of just 1. I'd also make sure that I do some reviewing on this A7B. You will have just finished quadratics, but because this one is worth 4 questions, I would spend a little bit of time on that. And then finally, I would spend time on linear. It would have been a semester since you've touched on linear, unless you've been reviewing it or making connections. Every time you talked about an exponential function, we bring linear back. Every time we talk about quadratic, we bring back linear and exponential, and we compare and contrast our functions. Unless you're doing that, then you'll need to spend a majority of your time probably on the linear function piece. All right, so know that your coaches and I are here for you. We know that you are working hard, and we thank you for our hard work for our students. And if you need anything, let us know. Other than that, happy Friday, or whatever day you're listening to this. We'll talk to you soon. Bye.